Hello everyone, my name is Muhammad Nadim from Mechanical Engineering. Subject Probability and Statistics. My TikTok topic on continuous random variables. Continuous random variables. Continuous random variables are measurements or observations that can take on any value within a specified range. They differ from discrete random variables which can only take on certain distinct values. Definition and characteristics. Step 1. Continuous domain. Continuous random variables have an uncountable infinite number of possible values within a specified interval. Second one, probability modeling. The probability of a continuous random variable taking on any specific value is 0. So we use probability density functions to model their behavior. Third one, measurement precision. Continuous random variables can be measured to any desired degree of precision, limited only by the measurement instruments. Probability density function PDF. Definition. The probability density function PDF describes the relative likelihood of a continuous random variable taking on a given value. Properties. The PDF which probability density function is non-negative and the total area under the curve is equal to 1. Interpretation. The height of the PDF curve at a point represents the relative likelihood of the random variable taking on that value. Cumulative distribution function CDF. First one, definition. The cumulative distribution function CDF gives the probability that a continuous random variable is less than or equal to a given value. Second one, properties. The CDF is a non-decreasing function that ranges from 0 to 1 as the input variable increases. Third one, relationship to PDF. The PDF is the derivative of the CDF and the CDF is the integral of the PDF. Expected value and variance. Expected value. The expected value or mean represents the central tendency or average value of a continuous random variable. Variance. The variance measures the spread or dispersion of a continuous random variable around its expected value. Covariance. The covariance measures the joint variability of two continuous random variables. Standard deviation. The square root of the variance. The standard deviation is a measure of the typical deviation from the mean. Uniform distribution. Constant probability, finite range, and common applications. The constant probability. The uniform distribution has a constant probability density function over a finite interval. Finite range. The random variable is conformed to a finite interval with equal likelihood of any value within that range. Common applications. Modeling random events like rolling, dicing, or sampling from a population with equal representation. Normal distribution. Bell shaped curve, first one. Second one, parameters. Third one, ubiquity. First one, bell shaped curve. The normal distribution has a characteristic bell shaped probability density function. Parameters. It is fully characterized by two parameters, the mean and the standard deviation. Third one, ubiquity. The normal distribution is widely observed in natural phenomena and is central to statistical inference. Exponential distribution. First one, memoryless property. The exponential distribution models the time between independent events in a Poisson process. Second one, constant hazard rate. The probability of an event occurring in the next time interval is independent of the time since the last event. Third one, applications. Modeling the lifetimes of electronic components. Waiting times in queuing systems and arrival of customers in a store. Applications of continuous random variables. Science and engineering, finance and economics, quality and control. Science and engineering. Modeling physical measurements like weight, height, temperature, and electrical signals. Finance and economics. Analyzing stock prices, exchange rates, interest rates, and other financial time series data. Quality control. Monitoring and improving manufacturing processes by analyzing continuous measurements. Key takeaways and conclusion. First one, continuous versus discrete. Second one, probability and modeling. Third one, important distributions. Fourth one, widespread applications. First one, continuous versus discrete. Continuous random variables have an infinite number of possible values. unlike discrete random variables. Second one, probability modeling. Probability density functions and cumulative distribution functions are used to model continuous random variables. Third one, important distributions. The uniform, normal, and exponential distributions are fundamental continuous probability models. Fourth one, widespread applications. Continuous random variables have a wide range of applications in science, engineering, finance, and more. Thank you.